Hello and welcome to quadratic functions. We go into a lot more detail than we have in the past when we've looked at these guys like that. So our first example, this is in vertex form already, so we can identify all of these things. I'm going to fill in the blanks that you see here. So our leading coefficient is -1, which is less than 0. So that tells us what about the vertex? It is a maximum. And the specific maximum value is the y value, -2. It occurs at 4, the x value. The vertex is a point, so we like writing them as points right there. The axis of symmetry from the vertex as well, x equals the 4. And the range, because this is a maximum, will go up to the -2 like that. All righty, we want to look at the y-intercept. We're going to plug a 0 into the x value and evaluate the function. And always write intercepts as points, always, like that. So think about the range that we just looked at, and can you analyze and determine what that means for the x-intercepts? Think about it for a second. Pause the video. All right, well, let's just go to find those guys. We're going to set the equation equal to 0 and solve it like that. So add the 2, multiply by the negative, take the square root, and you probably have a clue about the x-intercepts at this point right here. Yes, that is an imaginary value, and they are not x-intercepts. Let's finish the solution off by adding that 4 there. So we do call these things roots or zeros, or in the past we solved equations, solutions like that, but they are not x-intercepts. Remember to take that negative in the root and turn it into the I outside of the root like that. Let's look at graphing. So when you're graphing these, start with the points that you have. And we only have 2 points, right? We've got the vertex, we've got the y-intercept, like that. We know the vertex is a maximum, and there are no x-intercepts. So to help us graph it, let's use the symmetry and plot a point symmetric with the y-intercept, like that. And now we can connect the dots in a parabola-looking shape. Good to go.